Exercise 3.3 of trigonometric functions. Question, we have completed 1 and 2 question. Now question number 3. In question number 3, all the sums are prove the following. All the sums are prove that. So now see the first sum. In first sum one correction is there. First sum, sine inverse of minus 1 upon root 2 is there in the textbook. If you take minus 1 upon root 2, the answer doesn't comes minus 3 pi by 4. So here one correction is there. Instead of minus, do the plus. So sine inverse of plus 1 upon root 2 minus 3 into sine inverse of root 3 upon 2. We have to prove this is equal to minus 3 pi by 4. So now in first sum, how we have done, we have to do this separate, find the values of principal values of these two and then add it. Okay, subtract it. So first we will take sine inverse of 1 upon root 2. So let sine inverse of 1 upon root 2 is equal to x. So take this sine this side, it will become sine x is equal to 1 upon root 2. Now sine x, value of sine x is equal to root 2, that is at angle pi by 4. Sine pi by 4 is equal to 1 upon root 2. So sine x is equal to sine pi by 4. Now what is the domain of sine inverse? So principal value of sine inverse is minus pi by 2 to plus pi by 2. So pi by 4 lies between this domain. So value of x is equal to pi by 4. Now what is our x? Sine inverse of 1 upon root 2. So sine inverse of 1 upon root 2 is pi by 4. Now this 3 we will not take now. Now take this sine inverse of root 3 by 2. So let sine inverse of root 3 by 2 is equal to x. Take this x sine this side, so it will become sine x is equal to root 3 by 2. When is value of sine root 3 by 2? At pi by 3. So sine x is equal to sine pi by 3. Same sentence you have to write. The principal value of sine inverse is pi by 2 to minus pi by 2 to pi by 2. So this pi by 3 lies between this interval. So x is equal to pi by 3. So this is our x is sine inverse of root 3 by 2 is equal to pi by 3. Now write down LHS. So LHS we got pi by 4, this value pi by 4 minus 3 into this value is pi by 3. This 3 gets cancelled. Pi by 4 minus pi, do cross multiplication, pi minus 4 pi upon 4 is equal to minus 3 pi upon 4, which is equal to RHS. So hence proved. Now see next sum. Now see third one. Now third one is different because see here values. In first sum we were knowing the values from the table. So here we don't know, these values are not there in the table. See 3 upon 5, 12 upon 13. So here, see here what we will do. Let now first value will take sine inverse of 3 upon 5 is equal to x. Sine we will take this side, it will become sine x is equal to 3 upon 5. Now we know the identity sine square x plus cos square x is equal to 1. Now we will write the sine in terms of cos. So cos square x is equal to 1 minus sine square x. So cos x means taking square root of both the sides, we get cos x is equal to under square root sine 1 minus sine square x. Now what is our sine x? 1 minus 3 upon 5 bracket square, that is 1 minus 9 upon 25. Do cross multiplication, 25 minus 9 upon 25, that is 16 upon 25. Take square root, you will get value cos x is equal to 4 upon 5. Now we will take the second value. So let cos inverse of 12 upon 13 is equal to y. Take this cos this side, cos y is equal to 12 upon 13. Now we will find cos value in terms of sine. So sine y is equal to, using same identity, under square root sine 1 minus cos square y, that is 1 minus 12 upon 13 whole bracket square, That is 1 minus 144 upon 169. Do cross multiplication. You will get 25 upon 169. Take square root 5 upon 13. So we got value of cos x and cos y. Now we know the formula of sin a plus b or sin x plus y. So sin x plus y is equal to sin x cos y plus cos x sin y. Here plus sin is there. Now sin x plus y, we know the values of sin x, cos y, cos x, sin y. Substitute. So sin x is 3 upon 5, cos y is 12 upon 13, cos x is equal to 4 upon 5 and sin y is equal to 5 upon 13. So this 5 upon 13 into 5 65 here also. So we want here 65 only. So don't cancel anything. Don't cancel this 5 and all. So this is 12, 3s are 36, 5 4s are 20. Add it, which comes 56 upon 65. But we want here sin inverse. So now here sin x plus y is equal to 56 upon 65. Take this sign this side, it will become sin inverse. So x plus y is equal to sin inverse of 56 upon 65. Now what is our x? See here what we have assumed. X is equal to sin inverse of 3 upon y. Write it here. And y is equal to cos inverse of 12 upon 3 is equal to sin inverse of 56 upon 65. So we have proved it. So write down hence proved. Next one. Next one, say fourth one. Now we have this also formula to remember for this sum. Cos inverse of 3 upon 5 plus cos inverse of 4 upon 5 is equal to pi by 2. Now here also this 3 upon 5, 4 upon 5 are not there in the table. So here remember you have to use the formula. See here we want value pi by 2. So we have to remember the formula. Sin inverse of x plus cos inverse of x is equal to pi by 2. So first we will assume first value. Let cos inverse 3 upon 5 is equal to x. Therefore cos x is equal to, take cos this side, is equal to 3 upon 5. Again same formula. Sin x is equal to under square root sin 1 minus cos square y. Okay. Cos x is equal to 3. From here we will get cos x is equal to 3 upon 5. Now sin x is equal to, here x should be there, 1 minus cos square x. We are having value 3 upon 5. So 1 minus 3 upon 5 bracket square, that is equal to 1 minus 9 upon 25. That is equal to, do cross multiplication, 25 minus 9 upon 25. Root 16 upon 25 is equal to 4 upon, sin x is equal to 4 upon 5. Up to here like back sum, that is sin x is equal to 4 upon 5. Therefore x, take sin this side, x is equal to sin inverse of 4 upon 5. Now here we have written here 1. So see here what is here x. Here x is cos inverse of 3 upon 5. Substitute in that. So therefore what is value of x here? Cos inverse of 3 upon 5. So here instead of x we will write cos inverse of 3 upon 5 is equal to sin inverse of 4 upon 5. Now so this we got. Now write down LHS. We want to prove this as pi by 2. Now LHS is equal to cos inverse of 3 upon 5 plus cos inverse of 4 upon 5. Now cos inverse of 3 upon 5 is, you have to substitute this sin inverse of 4 upon 5 and this as it is. So see here what is our formula. Here also x is there, here also x is there, means same. Here also see same it came, 4 upon 5, 4 upon 5. So using this formula, sin inverse of x plus cos inverse of x is equal to pi by 2. So we have written here since sin inverse of x plus cos inverse of x is equal to pi by 2. Hence proved. Next one is fifth one. Tan inverse of half plus tan inverse of 1 by 3 is equal to pi by 4. Now here the formula which we have to use is tan inverse of x plus tan inverse of y is tan inverse of, here plus sign is there, so up plus will come, down minus will come, tan inverse of x plus y upon 1 minus xy. Okay, now write down LHS. Tan inverse of half plus tan inverse of 1 by 3, that is tan inverse of, use the formula, suppose this is x and this is y, half plus 1 by 3 upon 1 minus half into 1 by 3. Do your cross multiplication, you will get 5 upon 6 and 5 upon 6, which will get cancelled, you will get tan inverse of 1. Now we know tan pi by 4 is equal to 1. Suppose you take tan this side, pi by 4 is equal to tan inverse of 1. So we got the value of tan inverse of 1 is equal to pi by 4, which is equal to RHS. Hence proved. So here this formula, applying this formula is very important. Now next one is 2 tan inverse of 1 upon 3 is equal to tan inverse of 3 upon 4. So first write down LHS. LHS is 2 tan inverse of 1 upon 3. So here 2 tan inverse is there, so we can write it as 1 tan inverse 1 upon 3 plus 1 tan inverse 1 upon 3, which becomes 2 tan inverse 1 upon 3. Now again same formula, this same formula we will use here. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. So you will get here cross multiplication. So here after doing cross multiplication, you will get 6 upon 9 upon 8 upon 9. So take it upside, you will get tan inverse of 3 upon 4, which only we have to prove. Only here which formula? This formula is important. That and first step what you have to take, 2 tan inverse of 1 upon 3, write separately and take and use this formula. Automatically you will get tan inverse of 3 upon 4. Next is tan inverse of cos theta plus sin theta upon cos theta minus sin theta is equal to pi by 4 plus theta, and range of theta is also given. Now again same formula of tan inverse we have to use here. So we have to convert this into 1 and this into tan theta. So for that what you have to do here, divide numerator and denominator by cos theta. So each term divide by cos theta. So after dividing, you will get here cos will get cancelled, here it will remain tan. So 1 plus tan theta upon 1 minus tan theta. Now value of tan pi by 4 is 1. So instead of 1 we will write tan pi by 4 plus tan theta 1, this one as it is 1 minus, now here we can write it as 1 into tan theta also. So instead of that 1 we will write tan pi by 4 into tan theta. Now that only formula reverse we will use. So in this form we got, which means tan of x plus y, that is tan of, this is x and this is y, pi by 4 plus theta. See same formula, only we have reversed it, means this is equal to this we were using, now we will use this, we got this in terms of this is equal to tan x plus y. So this tan inverse and tan will get cancelled and we will get pi upon 4 plus theta, which is equal to RHS. Hence proved. Next one, see tan inverse of under square root sign 1 minus cos theta upon 1 plus cos theta is equal to theta by 2. Now here see two important formulas are there. Cos 2 theta, two formulas are there for cos 2 theta. Cos 2 theta is equal to 2 cos square theta minus 1. So we want here 1 minus cos theta. So here cos 2 theta is there, this 1 will take this side, so it will become 1 plus in terms of this we want 1 plus cos 2 theta is equal to 2 cos square theta. Now here 2 theta is there, we want theta, so divide the angle by 2, so here also and here also, so here what you will get, this 2 will get cancelled, and 1 plus cos theta is equal to 2 cos square theta by 2. So for numerator we got this 1 plus cos theta. Now we want 1 minus cos theta. One more formula of cos 2 theta is cos 2 theta is equal to 1 minus 2 sin square theta. See, first formula is 2 cos square theta minus 1, and one more formula is cos 2 theta is 1 minus 2 sin square theta. Now we want here 1 minus cos theta. So here cos 2 theta is there, so 1 we will keep here, and this cos 2 theta will bring here, so this 2 sin square theta will go there, so 2 sin square theta is equal to 1 minus cos theta. Cos 2 theta, we want here theta, so we have to make it half angle, so here divide by 2 and here also divide by 2. When we will divide by 2, this 2 and 2 will get cancelled, so we will get 1 minus cos theta. This we want 1 minus cos theta, and here 2 sin square theta by 2. Now write down LHS. Tan inverse under square root sign 1 minus cos theta upon 1 plus cos theta. So under square root sign 1 minus cos theta is equal to 2 sin square theta by 2, and 1 plus cos theta is 2 cos square theta by 2. 2 will get cancelled, and sin square theta by 2 upon cos square theta by 2 is equal to tan square theta by 2. And remove the square root sign, you will get tan theta by 2, and this tan inverse. So tan inverse and tan will get cancelled, and you will get theta by 2, and that only we have to prove that is RHS, which is equal to RHS, hence proved. So we have completed all, prove the following, which are very easy, only you should know the trigonometric formula. So remember this 3-4 trigonometric formulas perfectly, you can solve these sums very easily.